So thank you for this opportunity to talk about how indoor drones are starting a revolution in the middle of inspection, and especially in the confined spaces inspection. So you can skip the slide. I'm just going to start with a few words about Flyability. We are a team of around 100 people based in Lausanne, in Switzerland. We started with Fukushima. Basically, Fukushima really put us on the spotlight because the outdoor drones were already mature enough, but there was no solution to go inside buildings in a GPS denied environment, in hostile places where you could resist collisions and stuff like this. So what our engineers built from the PFL in Lausanne, they built a series of prototypes of a drone inside a cage that could resist collision and evolve in those kind of difficult places. So the whole vision of Flyability is really to send robots instead of humans in dangerous places, especially in confined spaces. So based on this, we got a lot of innovation prizes on the safety side and the inspection side. And now those figures, they show that from 2 people in 2014, we're now close to 100 people. So the growth has been great, and we're able to address the whole world with a solid network of partners. So yeah, that's the mission is really coming from a safety angle, that we don't want to send humans in dangerous places. And the second part of that is that we are convinced that the world of tomorrow for the inspection will be done through robotics, thanks to improved image quality and other type of information. These are just a couple of statistics about the number of victims linked to a confined spaces entry. Most of the time is due to lack of oxygen, but also other type of casualties due to the shoot from altitude and stuff like that. And what we're really trying to do is to prevent those accidents. And at the same time, we have a big impact on the cost as well, because the preparation costs are very important in terms of safety, and this is something that we can address. And finally, the downtime is a huge element as well. And when you're able to basically inspect an area in 10 minutes with a drone, it's a really a big factor of gain for those industry people, because usually they need to build scaffold. It takes weeks to mantle and to dismantle, and if you can do that very quickly with a drone, it saves a lot of time and therefore money. So these are the 3 big benefits: safety on one side, but also reducing the downtime for the industry, and improving the costs, the operational cost efficiency. Then these are a couple of customers that we have in our, like a couple of selected customers. This is just to show that this is a recognized solution now, pretty much everywhere in the world. And we are active in a lot of different sectors, as you can see from those names coming from different areas. Anywhere where you have confined spaces is actually relevant. So it can be in the chemicals, it can be in the maritime, the oil and gas, food and beverage, and power generation. So these are basically the couple of elements about our drones. I'm not going to go through all of them with this slide. I think it's better if we see a small video where I go through what makes it very different from the other types of drone, and especially outdoor drones.
Put their lives at risk to perform visual inspections in complex environments. Their work demands tools that stand for simplicity, precision, and high reliability to maintain capital-intensive assets. This is Ilias 2. Made for indoor inspection, it's the most intuitive, reliable, and precise drone designed for the tough jobs. Imagined by top inspection professionals, brought to life by our engineers, it's built to keep workers out of harm's way, gain efficiency, and drive costs down. Ilias 2 is remarkably intuitive to fly, making anyone feel like a seasoned pilot right from the first flight. Take razor-sharp close-up images in GPS-denied environments, in dark and troubled airflows, beyond line of sight. Follow long and repetitive features, welding or beams. Ilias 2 remains at the right distance autonomously. fly reliably in confined spaces, go around corners, and capture every inch of the most complex asset. Lightning-fast corrections on the propeller's speed and rotation direction keep Helios 2 stable at any time. When it comes to certified visual inspections, data is what matters. So we've placed Helios 2's payload in the front cage opening, fitted with a thermal and a 4K camera side by side. 12 megapixel still and video recording gives you stunning detailed images with 0.18 millimeters per pixel resolution to spot the tiniest cracks from floor to ceiling. The Helios 2 features the most powerful and intelligent lighting system ever built on a commercial drone. 10,000 lumens of light give you an increased situational awareness in large spaces. Indirect dust-proof lighting allows you to traverse dirty places without losing sight of your objective. Detecting pitting and cracks has never been easier. An oblique lighting mode reveals the texture of surfaces by creating shadows in all asperities. Because failure is not an option, a robust wireless system carries full HD live video feedback, allowing you to perform real-time inspections and make sure you always leave the site with a complete data set. The Helios 2 optimizes the way you work, from flight planning to data analysis. Preparing reports, taking 2D measurements, or building 3D models only takes a few clicks. A modular design makes Helios 2 easy to service and minimizes the reasons to ever send your drone back to flyability. The Helios 2, a major asset for those who care for their workers' safety, processes efficiency, and operating costs.
There you go. So yeah, sorry for this very Hollywood style video, but I think it was great to see all the aspects of the technical aspects, what makes it different from a normal drone, especially with the GPS denied environment navigation system. So this is an important one. We have also something that we haven't touched in this video, which is the live localization. I mean, the data localization inside assets. So again, here it's a video from a customer. So sorry about the Chinese language. But what we are able to do now is to really, right after your inspection, you're able to build a sparse point cloud of the asset in order to be able to locate defects in the environment. So you will see it appearing at one point. So this is just the drone going inside. So you see here the lighting that is being adjusted, and yeah. So this is what I wanted to get at. So you see here there is a point cloud right after the flight that can be generated with the trajectory that the drone went through, as well as the exact position of the point of interest that you have found in the environment. So you don't see it very well here, but you have XYZ coordinates in the bottom left of the screen that will tell you exactly where the defects are located, which was a huge demand from the inspectors, because from just a simple inspection video, sometimes it's a bit hard to know where you are in the environment. So this is great to also have an efficient maintenance after that. In the software, you can also, zoom, you can make some 2D measurements, create some automated reports. So this is just a small example of photogrammetry indoors. So this is the next step. So this is another type of 3D model where you can really get laser sharp details and make other kind of measurements like distance, volume, surface, or perimeter, diameters, and stuff like that. So this is more for let's say more experienced pilots and experienced photogrammetry specialists. Yeah, this is a quick other example in the oil and gas industry where we can do that with a sphere, for example. So here you see how the software looks like, and we're able to create digital twins to better track the life of the assets. So this is pretty much it in terms of product. If we look at a couple of case studies from the field, we are pretty much very present in the oil and gas industry, which is a big industry in Belgium. So one of the most common use cases is the oil tank inspection, which is quite a vast asset. And here the difficulty is to get to the higher places, the walls at a height, or the structure of the roof, which is always a bit tricky to inspect. You usually need rope access, and most of the time, those people with rope access, they cannot access the sides of the asset. So here, using the drone is a very good opportunity. I would like to advance a little bit on the video, but here I cannot really do that. But you will see the structure of the roof at one point. And here we're able to have this inspection done in 4 hours instead of 2 weeks. So that's huge in terms of a downtime reduction. And you have also some significant cost reduction based on the scaffolding that were avoided, but also the downtime of the production that we're able to get. And on top of that, you have very high quality data that you can use for future reference. Another good example is a cracker in the oil and gas industry, still in the oil and gas. So these are very tricky areas to inspect. And here with the drone, even with the diameter, which is quite small, we are able to get it. It's very vertical kind of chimney. And here also we're able to get like 4 hours instead of 3 days. So in terms of downtime, it's pretty significant, and we're also able to create such models of photogrammetry where we're going to measure a specific depth of a product, for example, of an asset. So this is extremely valuable for industry owners because they can replicate this model the following year and then compare the depth of a defect, for example. This is another example which is quite common, and you can see here our software at the same time. It's the chimney inspection, so very similar to what we saw before with the vertical asset. Here, the data localization is important because the asset owners, they really need to understand where the defect is located in order to simplify the maintenance operations afterwards. So here, again, 2 hours instead of 2 days to build that. Usually you need to send people at height with rope access. There's a risk of fall in injuries. You rely on the eye of the inspector that is there, or the guy on the rope. And at least with the drone, you have a reliable data with powerful lighting. You can take many angles of the light, and you have a movie and data that you can come back to after even the following year. So this is just a quick example of another photogrammetric example where on top of just the visual inspection, we can do another 3D model, and you can make some surface measurement. Yeah, you will see this right away, where thanks to the point cloud, the customer wanted to understand how much of the refractory had fallen from the top of the chimney. We can do that thanks to the software capabilities, of course, with external partners, photogrammetric partners. But this is a great help for the maintenance teams. Okay, so this is I think we went through this one, and one of the important let's say sectors, especially in the Benelux, is the inspection of huge cargoes. So cargo tank inspection, for example, and here again. The downtime is very critical because the immobilization cost of such boat is tremendous. So if you're able to perform inspection much faster, you're going to bring a lot of benefits for those cargo owners. So here we were looking for cracks. I mean, our customers were looking for cracks in a boat like this one. They were able to perform the full cargo tank inspection in 2 hours instead of the usual 10 days which are required with the scaffold and so on. And we found the defect that if this defect hadn't been found, it would have cost around $2 million for for the asset owner in terms of immobilization costs. Okay, a couple of other inspection application in the refineries. So any kind of pressure vessel, furnaces, distillation columns, flare stacks, water tanks, pipe racks, or any kind of underground sewers, for example, are very good use cases. And yeah, okay, that's just a quick example for a sewer. For example, this was done in Belgium, by the way, with one of our customers. This one is really interesting because not only we are able to go inside those very hostile places where there's a risk of a slippery or structure collapse, of water increasing and stuff like that, and also a risk of lack of oxygen. Here we are able to find a defect like this one and to precisely measure how much the deformation, how big is the deformation. So this is done with a photogrammetric model as well. We're able to perfectly locate this problem and to measure the criticality of it. I think that's it from my side. Thank you very much. If you have any questions, feel free to ask.